In section 8.6 of the finance unit, we're going to talk a little bit about the mathematics of financing a car. So this is going to go kind of in the opposite direction. In our last lesson, we talked about an annuity where we were saving money toward a future value. This time, we're going to have a present value, which is a loan on a car. We're going to make payments in an effort to get its future value to be zero. So these are called installment loans, and it does allow you, by getting an installment loan, that means that you get to get the product immediately. So you didn't have to actually save the money for a car before you got it. So you pay for it and you're already using it. The disadvantage of an installment loan is that interest can add a substantial amount to the cost of the purchase. All right, let's take a look, and you'll, I hope, very quickly recognize that you really already know what to do. All right, number one. It says, suppose that you borrow $15,000 for 3 years at 6% toward the purchase of a car. Find the monthly payments and the total interest of the loan. All right, the monthly payment. For an installment loan, it's kind of the reverse of the annuity. Let's go ahead and fill in, take a minute, pause this if you need to write down those items that you're going to use for the TVM solver. And let's see. The interest rate is 6%. The present value is $15,000. If you want to, you can put it as a negative. If you put it as a negative, your payments will be positive. If you put it as a positive, your payments will be negative because they're trying to work against each other. We're looking for your payment. Future value in an installment loan, your future value is 0. We are paying monthly payments, so payments or periods per year is 12. We're doing this for 3 years, so our N is 3 times 12. All right, let's solve for payment. Let's see what it does. Move this over. Oh. Remember, it won't let you move off of something that's blank. All right, so N 3 times 12, or you could have just put the 36. Interest rate, 6%. Present value, 15,000. Payment. We'll skip that. Future value, 0. We want to pay off the loan. This is paid monthly, so the 12s are already correct. So I'm going to go back up to payment, do alpha, enter, and move my cursor off of that. Okay. And I want to grab this. Maybe make it a little smaller. Whoops, you know, I really don't like the fact that I did that. I'm going to put it perhaps right there. Okay, well, it messed up my list over here, but I have it repeated within this. All right. So my monthly payment is near a cent. So it's going to be $456.33 because the 9 will have us round that up. Now it says find the interest. All right, well, let's just look at this logically. The interest. It's the difference between what you owed and what you actually paid. So this time what you pay is more than what you originally owed, so it's going to be your total payments minus what you owe, which we called your present value. So you paid $456.33 per year for 36 months. I think I said it wrong. $456.33 per month for 36 months. So that will get your total payments, and we will subtract from that $15,000. Your home screen of your calculator will do this for you. Do a second of the mode, which is quit. I'm going to clear my screen. It is 456.33 times 36 minus 15,000. The difference between those is my interest. It is $1,427.88. And I will leave that down here also. All right. So you can see that although we're going backwards, we take out a loan, we pay it off, it is still working with repeated installments on compound interest. All right, let's look at number 2. Suppose that you decide to borrow $16,000 for a new car. You can select one of the following loans requiring monthly payments. A, 3-year loan, 5.1%. B, 5-year loan at 4.8%. We need to do A through C. Okay, part A, monthly payments for loan A, then the interest for loan A, then monthly payments for loan B, and the interest for loan B, and then we'll do a comparison. So, loan A. Let's see, that was the 5% 3 years. Okay. I'm sorry, 5.1%. So it's 5.1%, 16,000, payment unknown, future value 0. Doing this monthly, so that's 12 and that's 12, and it is 12 a year for 3 years. We'll do that in just 1 minute. Loan B. The interest rate is a little lower, 4.8. We're still borrowing $16,000 for the car. Trying to figure out the payment. Future value 0. Still 12 and 12. Another thing that's different is that we're doing this for 5 years, so it is 12 times 5. So we're going to look at what this payment will be. 3 years at 5.1% versus 5 years at 4.8%. So, calculator. I'm going to go to Apps, Finance, TVM Solver. I need 12 times 3 is 36, so I can leave that. Interest rate, 5.1. Present value, 16,000. I'll come back and figure out the payment. Future value 0, 12, 12. All right, go back up to the payment, alpha, enter. The payment is $480.25. Double check that. $480.25. Okay, let's change the conditions. Now the number of payments is 12 times 5, which is 60. You could put 12 times 5 in there. The interest rate changes to 4.8. Everything else staying the same. Let's go to payment, alpha, enter, and it is the payment is $300.48. Put that back up if you want to see it again. The 5 causes the 7 to round up. Okay? All right, the next thing I need to do is figure out I believe, although maybe I'm doing this out of order. Whoops. Go back. So I have answered this. I have an answer to this one, and I have an answer to this one, and I need to get the interest on each one of them. Okay, how do I get interest? The interest is your total payments minus your present value. All right, so for this one, there were 36 payments at $480.25, and the present value was $16,000. For this one, the interest is, there were 60 payments at $30.48, and the present value was the same. All right, so let's calculate. I have 36 times well, it's trying to scoot that over. There we go. 36 times 480.25 minus 16,000. That gets me interest of $12.89. Now, I have 60 times the payment, which was 348 cents, minus present value, 16,000. And I have $2,028.80. Let me double check that. Yes. So I think you can see that if you extend your loan, even if you have a lower interest rate, yes, your payment is smaller, you end up paying back significantly more. You pay a lot more back in interest. In this case, over $700 more. All right, so we found the answer to the loan payment for A, the interest for A, the loan payment for B, the interest for B, and now it says compare them, which loan is more economical. And it turns out that the 3-year loan is more economical, and it says you will save how much interest. Okay, loan A, you paid, loan B was the big one. Loan B, you paid $2,028.80 in interest. Loan B, you paid $12.89 in interest. The difference between those is $739.80, and that's what you would save in interest by going with the 3-year loan. The 3-year loan, you pay less than the 5-year loan. Okay, so there were a lot of parts to this question. I didn't write them in here, but I do have them all here. If you print the notes, You will find this hopefully in a very organized form as well. Let's take a look at question number 3. All right. In this one, you're thinking about buying a car and have narrowed down your choices to 2 options. You have a new car option. It costs $28,000, financed for 4 years, 6.69%. Used car, it's a 3-year-old model of the same car. It costs $13,000, can be financed for a 4-year loan at 7.61%. What is the difference in the monthly payments? Okay, let's see. All right, this will be our new car, and this will be our used car. And you can always stop this video and take a moment to write these items down. All right, for the new car, it is 6.69%. The present value is $28,000. Payment is unknown. Future value is 0. You're paying it monthly. You're paying it monthly for 4 years, so that's 12 times 4. Okay, we'll figure out that payment using the TVM solver in just a minute. Used car. You have an interest rate of 7.61. The present value is only $13,000. The future value is still 0. We're still paying it monthly. And for this one, it is a 4-year loan also, so it is 12 times 4. It seems like what's different is the amount of the loan, which is the present value, and the interest rate. So let's take a look at the new car. Come on. App, Finance, TVM Solver. All right, I have 12 times 4. That should be 48. The interest rate is 6.69. Present value, $28,000. And everything else is the same. I'm on payment, alpha, enter. And the payment is $666.48. 666,475. The 5 causes that to round up. All right. Let's change it up. The interest rate changes to 7.61, and the present value changes to $13,000. Go to payment, alpha, enter, and the payment is $314.99. Okay, now it does not ask me to give those payments. It simply says, what is the difference? Okay. So I will take 6648 minus 31499, and I get, I'm not even going to show it on the calculator, but I get $351.49. Okay, and I lost a 6 here, sorry. All right, so hopefully you're feeling very good about using the TVM solver. Number 4. Suppose you decide to buy a car for $23,635, including taxes and license fees. You save $5,000 for a down payment, and you can get a 5-year car loan at 5.36%. Find the monthly payment and the total interest on the loan. Now, this one is a little different because the amount you borrow is not, and the amount you borrow is your present value. The present value is $23,635 minus the down payment. They sometimes say you have to put a certain amount down. That means you come up with part of the cost and then you finance the rest of it. So if you do that subtraction, what you're going to borrow is $18,635. Sometimes the down payment takes the form of a car that you trade in that has a certain designated value. So the present value for my loan is $18,635. I will not use the down payment money anymore. 5 years, 5.36. Future value 0. Monthly is the most common period. Let's see. We're going to do it monthly for, and I said it just a second ago, 5 years. So that's 12 times 5. All right, let's see what the payment is. $12 times 5, which is 60. 5.36 is your interest rate. After the down payment, you're borrowing $18,635. And we can go ahead and calculate payment. Alpha, enter. It looks like your payment will be $354.75. So, payment is $354.75. How do we figure out the interest? Remember, just try to use your common sense. It is the difference between how much you paid and what you actually borrowed. So your total payments minus your present value, which is what you borrowed. The difference between those is what you paid in interest. Your total payments, you had $354.75, and you paid that, 12 times 5 is 60, minus, your present value, which is $18,635. I could do that on the home screen of the calculator, and I will get $2,650. And it says, oh, I guess, and 75 cents. All right. Let's go ahead and do that. I want to kind of double check it. I had something written down and I think it could be an error. All right. 354.75 times 60 minus 18635. Oh, I was right the first time. It is $2,650. That is what you're paying in interest. Okay, so monthly payment, total interest. Okay, our last problem is a little bit more involved. We are not going to use the formula that's up here. We are instead going to use our TVM solver when we need to. But let's take a look at this. So we don't need that. Suppose you drive 30,000 miles per year and gas averages $4 per gallon. Complete parts A and B below. Okay, let's do A. What will you save in annual fuel expense by owning a hybrid car averaging 30 miles per gallon rather than an SUV averaging 9 miles per gallon? All right, this formula is in your textbook. It's on page 544. I've also put it on the formula sheet. So let's figure out what the cost for gas will be in each of these vehicles, and then we'll see how much we save if we have the hybrid. Okay, let's look at the SUV. The annual fuel expense, it's annual, is the annual miles driven divided by the miles per gallon times the price per gallon. And you get to use this formula. So, annual miles driven is 30,000 divided by the miles per gallon, and the SUV gets 9, and we're going to multiply it by the price of a gallon of gas, which is $4. Okay, so you can do this exactly as you have it there. Clear my calculator. It is 30,000, I'm sorry, 30,000 divided by, divided by 9 times 4. And that is your cost per year. And let's see, it says round to the nearest dollar. So it's going to be $13,333. This is money per year. Annual fuel expense. All right, the hybrid. The miles driven is still 30,000, but the miles per gallon is 30. It still costs $4. So I have 30,000 divided by 30 times 4 is $4,000 per year. Okay. All right. What will you save in annual fuel expense by owning a hybrid? Okay. The annual will be how much you will save will be the difference between these two. So the savings is the $13,333 minus $4,000, which is $9,333 per year. All right. So that is the answer to question A. Question B. Now you got to be careful because there's something here that can sneak up on you. If you deposit your monthly fuel savings at the end of each month into an annuity paying 5.2% compounded monthly, how much will you have saved at the end of 5 years? Okay. Now, this savings is your annual savings. You don't save that much each month, and yet we need to put this into an annuity working on the month. So your savings is also 9,333 divided by 12. This will be money per month. So if I divide that, I will get $778 per month. And it's so easy to not read those units and to mess up on that. Okay, so question A asked me about the difference in the savings, or what the savings were, which is the difference, per year, annual. But now that I'm going to make deposits, I'm going to do it at the end of each month. So my payment into my annuity is going to be, let me scoot this down, my payment is going to be $778. My interest rate, I have to go back up and read, 5.2%. I'm going to do this for 5 years. All right, 5.2. The present value, I don't have any money yet. I'm starting my savings. My future value is what I'm looking for. And we're going to do this on a monthly basis. We're going to do it for 5 years, so it's 5 of those 12s. And I'm going to see what I have at the end of 5 years if I put my monthly savings into this annuity. So, app, finance, TVM solver. That's going to be 60 because 5 times 12 is 60. I have 5.2%. My present value, I'm saving and I don't have anything in there. I'm going to make payments. I'm going to make payments of $778 into this savings every month. And future value is what I'm trying to find. We haven't done one of these in a section or so, so this is different. Or hopefully it's familiar. So second, alpha. It is hard to believe that after 5 years, if you saved that much in gas each month, you would have to do some traveling to be saving that much in gas. You put it into an annuity, you would have, after 5 years, you would have $53,180. Saving every month over a period of time really begins to accumulate. This problem had us go back and think over things that we had done in previous sections. Okay, only 5 questions, plenty to work on.